I'm Nathan Skipper with Montgomery Technology Incorporated, and this is session 5 of the MTI Control System Technician Training course. And in this slide, we're going to begin to cover the termination hardware division of the MTI control system. We're going to begin with one of the workhorses of our control system, which is the locking termination board, or the 81623. And through the rest of this series, we're going to go through specific boards and teach you how to terminate and support those individual boards. The locking board, the 81623, has a number of features that I'll review here, and then I'll also explain the major components and connections for that device. First of all, it provides 16 dry contact inputs and outputs. Each side of the board, if you consider the sides as left and right in figure 0502 there, each side of the board provides 8 isolated inputs and outputs. That's designed to meet UL and NEC standards with respect to isolation, so that you could actually have one side of the board that had high voltage and one side that had low voltage, and you would meet all the standards for that. It supports 16 Omron G2R or IDEC RJ1S relays. Each input and each output has a 6.3 amp little fuse to provide fused connection to the lock. It supports most locks, both detention and commercial grade locks. Provides for dry contact interfaces. You can use it not just for locks, but also for interfaces with elevator control, gates, and those sorts of things. You can accomplish wet contact connections through an interposing relay, but this is an external connection that you would need to provide. So to go through the connections and components of this board, if you refer to figure 0502, the first connection that you'll notice up at the top is the data loop connection. This is for the data loop port coming into the board, and we'll go through that in the next slide in more detail. Next, you have the line voltage connection, and you'll notice you have 4 of those total on the board. We'll explain that more in the next slide as well. You also have 16 lock terminations that provide for the DPS and the output for the lock as well. You have the Omron G2R relay, 16 sockets for those. And then you have the fuse, the 6.3 amp fuse for each connection. And then the 81650 decoder is in the center of the board, and the addressing dip switch, which is used to determine where this board fits into the addressing scheme for the control system. Now, to speak specifically to the data loop and the line connections, we want to go through each data loop wire and then through each line wire to explain what each of those does. I'm going to start at the top of figure 0503 with a typical connection for the data loop. If you'll notice down at the bottom of this figure, you have the 2 line connections and the 1 data loop connection in the center. Both of those, or all 3 of those connections, are meant so that you can daisy chain those connections onto the next board. So the first from the right there is the 12 volts DC that you'll connect for the data loop wire. The next is the black wire, which is the common, and this is using the West Pin 850 wire that we recommend for this. The next is the D1, or the white, and then the next is the D2, and then lastly is the green, which is the clock. And then you'll simply wire that up going out of the board to your next board if you are daisy chaining these together. On the line voltage, you have 2 separate lines, as mentioned earlier. The first on the left hand side is line 1, and then you have neutral 1 and then line 2 and neutral 2. And as said before, you can daisy chain those out of the line voltage connectors on the bottom. One thing to note is, based on the addressing scheme, the left-hand side of the board is 00 through 07, and the right-hand side of the board is 10 through 17. We'll talk more about that in the next slide. Lastly, we want to cover the board addressing scheme, and this is true of all termination boards with the MTI system, but on this board you'll have a dip switch that's in the center of the board below the decoder board, and that dip switch has 2 switches to it. If you consider that switch from the left to right, if both switches are off, then it means that board represents addresses 00 through 17. If the left switch is off and the right switch is on, then this board represents addresses 20 through 37. If the left switch is on and the right switch is off, then this board represents 40 through 57. And then lastly, if the left switch is on and the right switch is on, then this board represents addresses 60 through 77. And this is important to correlate this board to the actual programming for the PLC.